Match Fishtank, Unit 8, Lesson 12. Here we're going to take a look at some anchor problems that ask us to analyze data represented in both numerical and box plot form. So for our first question, we have Lorna and her typical length of a movie, and our first question asks us to draw a box plot. Now we already have our 5-number summary. So I'm going to start by drawing a rather messy number line here. And I see that I have anywhere from 75 to 135 on here. I'm going to go ahead and start here with 70, just so I have a point. Let's go there is 80, 90, 100. 110, 120, 130, and 140. And of course I could go on more, but I'm just going to label a couple of these so I can count between them, mostly because I'm drawing this on my screen with my mouse and that doesn't work out very well for me. So now I'm going to take a look at plotting these on the chart. I see that I have 75 as my minimum. My lower quartile is 90. My median is 110. My upper quartile is 120. And my maximum is 135. And I draw my box around my lower and upper quartiles and add my whiskers. It's really helpful if you don't have the 5-number summary written right there to make sure you do write in those numbers. So I would, if I were just making the box plot and not showing somebody the 5-number summary, I would want to make sure I labeled each of these points. Don't make people guess. What kind of questions could I ask about the data shown in the box plot? Lots and lots of them. I could ask, for example, what the middle 25%, the middle 50% of the length of the movies would be. And that, of course, would be anywhere between 90 and 120. So I could say that a typical movie is probably in this range, with the median movie being at 110. I could ask what is the length of the longest movie that she surveyed, and that of course would be the maximum, 135, or what is the length of the shortest movie she surveyed. That would be 75 minutes. I could ask which movies are likely, what lengths of movies are in the lower fourth, and that would be shown here on our box plot, anywhere between 90 and 75. So there's a whole bunch of questions you could ask using the box plot. Now I'm going to sketch a dot plot of my data set. And I'm just going to do a very simple one. Wow, that's really messy. Sorry about that. All right. Actually, change my mind here. I'm going to switch colors and do it right on top of this box plot. So I know that there's got to be a point here at 75. I know that there's got to be a point here at 90. I don't necessarily know that. I could have another option in there. But I do know that there has to be a point here at 135. Now I'm going to go with the simplest possible set that I could do and imagine that every one of these 5-number summaries have their own number, and that then we have one in between each of them. So that is a very simple dot plot that I could have that would show this data. There's a lot of different ways that you can do it, and you need to remember that only the minimum and the maximum have to be numbers in the data set. My quartiles and my median could be found by finding the halfway point in between two numbers in the data set. As I scroll down to my next one, now I have a data set expressed in a box plot so that I can try to figure out what is going on here with this. So for A, what might explain the variability is the hand size. Maybe the person who grabbed only 7 was a small child. Maybe the person who grabbed 42 had really, really large hands. That seems like an amazing number of Tootsie Pops, so I'm imagining that that's in 2 hands. Even then, that seems really, really high. Still, that they could have a really gigantic hand. So if we're asked to determine the 5-number summary of the data set, we definitely know that 7 is down here. I can see that the lower quartile is 18. The median is here at 20. 22 is the upper quartile. And my maximum is the huge number of 42. What is the range of the number of Tootsie Pops that the middle 50% of people grabbed? So in this case, what I'm looking for is my interquartile range. This is the middle 50%. So if I take 22 minus 18, I have a range of 4. That's the interquartile range. The middle 50% of people grabbed in that area. True or false? We're going to have to zip up and down. More people grabbed between 22 and 42 Tootsie Pops than between 20 and 22 Tootsie Pops. Okay. More people between 22 and 42. Well, the number of people between 22 and 42 is 25%, because that's the upper fourth of the data. Between 20 and 22, that's also 25%. So no, that's false, because the same number should have grabbed there. The same number of people grabbed between 7 and 18 Tootsie Pops as people who grabbed between 18 and 20 Tootsie Pops. 7 and 18, that's 25% of the data points, and 18 to 20 is 25% of the data points. So yes, that's true. Let's mark these on here. So this one was false because they're the same amount. And II was true because they are the same amount. About 50% of the people grabbed between 22 to 42 Tootsie Pops. All right, 22 to 42. No, definitely not. That's only 25% of the people. So this is again false. The average number of Tootsie Pops grabbed was between 18 and 22. I think that's a reasonable statement because half of the people grabbed in there. So yes, I would agree that that's a reasonable statement. That's true. It must be true that at least one person grabbed 42 Tootsie Pops. 42 is our maximum, and somebody would have had to grab 42 in order for that to be our maximum. That would have had to have been a dot on the dot plot. So yes, that is true. And finally, it must be true that at least one person grabbed 20 Tootsie Pops. No, that's the median number. And so I could have had dots on either side of that median and have found it by finding the halfway point between those data points. So no, it is not necessarily true that at least one person grabbed 20 Tootsie Pops. All right, moving on down. Here we have some box plots for a class. And the first thing I'm going to do is I'm going to mark some data points on here. So I can see that the median point in all of these classes is 12. And it looks like the minimum on all of these classes was 5. And the maximum was 20. There we go. That'll help me take a look at some of this data. So one observation about how the data of all three classes are the same here are 3 of them. The minimum in each case is 5, the median in each case is 12, and the maximum in each case is 20. And this is a great example of when we'd want to give the interquartile range as well as the range, because if we are just looking at the median of 12 and the range of 20 minus 5 or 15, that's the same for all 3 of these classes. And yet there's obviously a very big difference in the way students did. So one observation of how class 1 and class 2 are different. In class 1, the middle 50% of the data was somewhere between, it looks like 7 here, and it looks like maybe 19 on this end. So the middle portion of this data was between 7 and 19, but in class 2, even though the median is still 12, the middle 50% of the data is all of it. That's kind of odd. That means that the upper quartile is the same as the maximum and the lower quartile is the same as the minimum. That must mean there were some repeated data values at 5 and some repeated data values at 20. So quite a few people, more than one, must have gotten 5 and must have gotten 20 in here. How class 1 and class 3 are different. Let's see, class 1, they both have the same minimum and maximum and median, but class 3 has as its lower quartile, or Q1, 9, and as its upper quartile, or Q3, 15. So half of the people got between 9 and 15. They're definitely more clustered together here than they are. They're more spread out in class 1. All right, so now, if I were a student in the class, well, it seems like I might want, in every single case, more than half of the people scored more than 12. And in every single case, half of the people scored less than 12. But I see here, it looks like these data points are more spread out. So it seems like there's only a couple of people in this class up at the high end, really could be only just one person up at the high end. And I suppose you could have a middle point there. So I would say class 1 would be the data that I would want to have there. All right, I think that does it for us.